Hello, welcome to Enots Engineering. My name's Alan. In this video we'll continue with making the Warden tool and cutter grinder. We'll use the brass bar to make the thumb screws and locking screws. We'll machine all the steel bars to length, and I'll show you a way to use your drill machine as a comparator. We'll deburr and fit the table sheet steel side plates. So let's start with the brass table clamps and thumb screws. Feed it in till the rollers start moving. Top one's moving, and the bottom one's just caught. I'll tighten this down a little bit. Feed it in. So the bottom one's just turning now. Just needs to be 1/4 of an inch. Feed it out. You can see that my parting off tool, the front face, has got a slight angle so that it cuts off on the right side of the tool, leaves a nice finish on the tool, on the part. I need to move that back, so it's got to be 1/4 of an inch from the face. I've got a 5mm die in the die holder, and I'm just bringing the tailstock in to support the back. Slacken the drive belt off so I can turn the chuck by hand. Feed it in as you turn the chuck. Back it off the thread. And feed the tailstock in at the same time. Just using the chuck key to help me turn the chuck. There's not a lot of force on this. As you come up to the face, that's locked on the face, you can remove the tailstock, back off the you can see, because of the leading of the die, it hasn't gone the thread hasn't got all the way up, so just turn the die round, because this side of the die, the thread goes right to the end. It's not got a lead in. So put it back on this way. Finish the thread off. See now the face of the die is coming up to the face of the job. Back off with the die. You could reverse the lathe for this and use a motor to remove it, but if you go the wrong way, you'll snap the handle off your die stock. So now I've got the thread up to the face. All that remains now is to part it off. Line it back up. Saddle again. Just lower the tool a slight bit. Piece of brass in there, lathe. I want to drill it, tap it and use that as the nut. Just put a 5mm tap in the tailstock, put it into the hole. I've not got the tailstock locked, so it can move forward and backwards when the tap feeds in. Once you've tapped the hole, take your screw it into there. And these are the components made from the brass bar. The next job is to machine the 2 spacer bars to length and the machine bearing bar. just want to show you a method, the way I used to check the lengths of bars when I didn't have a vernier that was long enough, especially when you want 3 or 4 bars the same size. First job would be to put this in your drilling machine chuck, turn the power off and just tighten it, nip it by hand. Do not tighten it with the chuck key because you'll crush the bush on the end and seize your dial indicator up. Next job, get 2 V-blocks that the bar you want to check the length of will sit in. So I've put the 2 V-blocks on the drill base, adjusted it so I can get the bar in there and it will just stand up on its own. Got your dial indicator held and basically use it as a comparator. Set the 0 to this one. Use that as your gauge. Machine the face on the others and just keep testing it until it's the same. When using your drilling machine as a comparator, if you move the table over like I've done here, the weight is transferred to the left, so it's important that you're careful the machine don't fall over to the left, especially when you've got a XY cross travel axis on like I have, which is quite heavy, so be careful when doing that. Or you may be able to just leave the table where it is and lower it down, but make sure the table is square, otherwise your bars will be out. This locks the travel in your spindle. You've got up to 2 inches of travel normally, so if your bar is shorter than that you need to pack your V-blocks up, but by locking this when it's in position it stops it moving. And I found that using the drilling machine as a comparator worked very well when I had some 300mm bars that I needed to get to within a thou for my Z-axis on the CNC. There's one thing you need to take care on, is when you're filing this groove slot out here, that's a 10mm register on there to slide up and down. And what I've found is this slot might be slightly out of position, so when you put this clamping screw in, you need to make sure that it's touching the bottom and there's no rock in it. I'll show you on the other side. This one, you clamp it there, you've got some rock in that, so if this was fixed up to your grinding wheel the whole unit would rock. So what you've got to do is file off the one side so that the base, the leading edge touches the base. File the bit off the top face so that the plates will drop down and slide on the lower ring. So when you lock this up, it doesn't rock. I'll file the edges, take the sharp edges off. So now we have to make the rails for the 2 lower ones, which are just stabilising bars, and this upper one here which has the cams on. This dial indicator cost me £5. When I bought it, it didn't work. It was locked. The finger was locked, wouldn't go around, and the rack wouldn't move in and out. So I took a gamble and thought, well, for £5 it may be useful for spares. Took the back off it, couldn't see anything wrong. Took the glass off, or the plastic cover, and it worked okay. Put the cover back on and it locked up. I'd noticed that somebody had replaced the plastic cover here and put a flat one in. Now these plastic lens covers have a dome on them, and the flat one was just squashing the finger against the rack, so it was locking it up. So all I did was took the plastic cover out, put a hairdryer on it, warmed it up, formed a slight dome, fitted it back together, and for £5, dial indicator with 2" of treble. I've spent some time finishing the bars off using the drilling machine as a comparator, so all the bars are now machine to length. I've temporarily fitted it together and I've made sure that it slides smoothly without rocking. I've also made the locking nut which goes on this side. All that needs to be done to that is the thread put on it, and I need to put the thread on the cam bar. This side doesn't have a thread. The next job making the right hand clamp nut needs this 1 1/4 inch bar. In my 3-jaw chuck the diameter would not go into the chuck, so it would have left it sticking out too far. So I've changed to a 4-jaw chuck which I can push right inside, lock it up so there's less chance of it vibrating. I'm just nipping the jaws up. That's close enough. Each division on this one is 0.01 of a millimetre, so it's running out about 0.03 millimetres, just over 1 thou. Okay. This side of the knurling tool is catching on the face, so I need to change that for another tool. I can't use that knurling tool either because the side of the tool is hitting the face. I've just made a knurling tool. This is an old lathe tool I had. I've cut a slot in the end, put a bolt through, nut and bolt, and luckily I've had a spare straight knurl. Now with this one I can get onto that, past this edge, so see how it goes. Gives a bit of vibration. But I think that's done the job. I've just parted it off, replaced the 4-jaw with a 3-jaw, and all I need to do now is face the end. In the next video we'll start making the 3 cam bosses out of a 1 1/4 inch bar. Well, thanks for watching, I hope you've enjoyed it, and we'll see you next time on Enots Engineering.